Hi all, welcome to this new lecture. So in this lecture we will build our first machine learning model in scikit-learn. Okay, and the algorithm that we will use for this model is k nearest neighbors. Okay, so let's understand what is first k nearest neighbor is. So it is classification algorithm. Okay, so basically it is type of supervised learning. So in supervised learning what we provide the input feature plus true labels, right? And then basically we'll have finite number of classes and we want to predict that. Okay, so we'll discuss about the problem statement in just second. Okay, but first let's understand what is k nearest neighbors or how does it work. Okay, so what it does basically, it takes k as some number as a input. Okay, and then it finds the nearest k nearest data point. Okay, and then it assign the label to the new data point based on the majority voting. Okay, so let's understand with the example. Suppose we have the data set like this. Okay, say we have two type of classes. One are like say yellow squares and other is green triangles. Okay, and now suppose for example we got the new instance here. Okay, and we want to know whether it would be yellow square or green triangle. So for that, first we will choose value of k. Say for example we choose value of k as a 3. Okay, and then we'll find the three nearest neighbors to it. So we'll have some distance metric, right? And then we'll find what are the three nearest data point to it. So in this case these are the three data points, right? So two are of them are basically triangles and one of them is square. So since triangles are more than squares, then we will assign this as a triangle. So this point will be a green triangle. Okay, so it works like this. For example, if new instance would have been here, then most likely it would be, or in fact it would have been the square, yellow square, right? And so on. So it is that simple algorithm. Okay, so it just calculates the distance of the k nearest neighbor and the assign the label to the data point based on majority voting. Okay, okay. So to implement this we must have some problem statement, right? So problem statement in this case is we'll work on the iris data set. Okay, so we had discussed about the iris data set in the last lecture, so we won't go in detail again. But as we discussed that sklearn comes with that inbuilt data set. Okay, so let me import that. Okay, and then assign that value to x, y, and let us show you. Okay, so if I import that and print x and y. Okay, so first let's talk about the x. So this is our basically input feature. So there are total 150 rows and each rows has 4 columns. So what are these? So iris is one flower, right? So it has sepals and petals, so their length and corresponding width. Okay, so that is the features that we have. And what is our model or our goal is to predict the model output. Okay, and model output is 3 categories: 0, 1, and 2. So these are basically category of flower that it belongs to. Okay, so our goal is for a new given instance like this, for example. So if we get the new instance with the corresponding sepal lengths and petal lengths and width, we should be able to identify to which category it belongs, whether it is 0, 1, or 2. Okay, so that is problem statement. So it is very classical classification problem, right? Because we have finite number of output true labels and we also have basically features along with the true labels. So this is supervised learning and within that it is a classification problem. So now let's use so now let's build our machine learning model using KNN algorithm that can predict our iris category. Okay, okay. So to build any machine learning model in the scikit-learn, okay, so there are just 4 steps. Okay, so first we have to import the class, then we have to instantiate object. Okay, then we have to train model, and then once we got trained model, then we need to predict on the new values. Okay, so let's discuss these steps one by one. Okay, so in our case, since we are working with the k near neighbor classifier, we will import its class like this. Okay, so from sklearn, which is our scikit-learn library, dot neighbors, from there we are importing knn neighbor classifier. Okay, So we will import that classifier as our first step. Okay. So once that has been imported, then next we will create the instance of this classifier. Okay, so that I can do like this. Okay, so k near neighbor classifier that we had imported, and here we'll give the value of n, or the value of k rather. Okay, so how many nearer neighbors that I want to look at. So for example, let's by default is 1, and we can give like this also explicitly. Okay, but like this I have created new instance called knn of k neighbor classifier with k value k as a 1. Okay, and if we print that, we will get same thing, it's knn neighbor classifier with value k as a 1. Okay, so next and most important step is training the model. Okay, so we have feature x that we talked about, right? 150 examples of sepal and petal lengths and widths, and we also have their corresponding true label, whether it is 0, 1 and 2 category. Okay, so since it is supervised learning, we need to provide these both. But to train the model, it is as simple as that. Whatever the instance that we had created, that knn dot fit. Okay, so fit is a method basically to train the model, and just it takes that x, y as a input. Okay, but with this one step we got our machine learning model. It's as simple as that. Now we got the machine learning model that we can use for the prediction. Okay, so let's try to predict then. So say for example, we got the new example like this, which has 3, 5, 4, 2 as a values. Okay, and as x is two dimensional, even if there is one row, we have to give as a 2 dimension. Okay, but say for example, we got this new value and we want to predict which category it belongs to, whether it is 0, 1 or 2. So for that, again we will use that same instance knn, and then method to use for prediction is dot predict. Okay, so it's as simple as that. So whatever the model we had built using that instance, so same instance dot predict and the numpy array. Okay, so if we give that, then we will give output as a array, but most importantly value is 2. Okay, so it is predicting that this new value is of category 2. Okay, say if we would have more such examples, so we'll have same 2-dimensional arrays like this, and if you would have predict again using same knn dot predict method, so it is saying this first example it is same anyways, so it is of category 2, and next example is of category 1. Okay, so now you can see how easy it is to build machine learning model using scikit-learn, right? It is just these 4 steps. First we will import class, then instantiate object, then we will just train the model using dot fit method, and then finally we can predict on any new values using predict method, and so on, right? So you can imagine, if you want to build this same algorithm that we discussed from scratch, how many steps or how many lines of code it would have been taken. Okay, and moreover, all these 4 steps are common across any kind of machine learning that model we are trying to build. Okay, only things would change is which classifier we want to use, that's all. Okay, so say for example, now instead of name k nearest neighbor, if I want to use logistic regression, then we would have used that instance, and the remaining steps would have been same. Okay, so like this, in only 4 steps we can build powerful machine learning models in the scikit-learn. Okay.